I started off this repair by first probing and seeing if I could find a short to ground. I did. And unfortunately, I started taking things apart before I started recording. So that's why we are where we are right now. I took two components out that I definitely knew were defective. Here I am just kind of probing it, showing the camera what values are being read. Of course, I'm confused right now because they were defective until I took them out. Realized here shortly that I took the wrong thing out. Fast forward. Right here is where I found the issue. And you can see what all these test out as. And here I am adding leaded solder to these components to make it easier to remove. We do this to lower the melting point. I'm just bending them down to make it easier to remove. Wiggle that side to side, make that drop out. You see that fault's been cleared now. We still have an issue over here though. We're just going to replace all four. I'm trying to figure out what route's best to take to get that new component in there. If I should just heat up that solder and slide it in, or if I should wick it away first. Of course, I decided to wick it. I hit the pads with some flux, and I'm just using that wick to pull away everything. Test fitting the component, making sure it'll fit through there, no problem. And yep, looks good. Now I've got a pretty good idea on how I want this to be on the circuit board. So I'm just going to tack in one leg real fast. Then solder the other side in. Repeat that same process on the other three. Add some leaded solder. Then drop it off the board. Come back and probe, make sure that fault's cleared. Add some flux. Just trying to clean up those pads. Then I'll come back with that wick. And I'll make sure that I get all that solder up off the board. I was too lazy to go grab my snips, that's why I'm leaving that long tail. Sometimes this can take a while. I'm just going to check the fitment on those three. Everything looks good. So just go ahead and clean off the circuit board now with some isopropyl alcohol. Now I'll go ahead and do the same thing. Position the next three components and tack one leg in. Zoom in to show off what I'm doing. And just solder in the rest of those points. Nice and shiny. Ooh, ah. And fast forward as we position things, test things, clean things, and finally move on to the portion that I screwed up at the beginning, getting these two perfectly normal components back in the board, and then cleaning them up, and finally putting this back together. I've got my variable power supply set up there, 12 volts, 1 amp. I try to fire it off, and for some reason I can't quite figure out what's going on here. Why is the light not turning on? Is it working? Is it hot? No. Why is it only outputting 5 volts? Is this a power button? No. So I try to change the voltage. I can't. That's when I realized that the input voltage there at the top also shows 5 volts. Unplug it from my power supply, pick a different port that's allocated for more power, and there we go, 20 volts. Now we can hit that power button and immediately turn on, no faults, the fuses remain intact. So call that a win. This is the following day. I'm just putting on connectors to test this amp out. Get a little heat shrink on there too, and map torch. Don't do this at home. Obviously don't point a torch at yourself. Learning from my mistake, I hold it a little higher that time. Looks good. Break out the oscilloscope. I'm just going to play a 50 hertz sine wave. And all I'm doing is adjusting gain. And of course here, I'm just showing off what clipping would look like, how the wave kind of squares off like that. So I'm backing off, increasing that gain until I'm happy with the wave. And that's it.